So my next task is to introduce our next speaker, which is a great pleasure so to do. Peter Arkwright is a paediatrician like myself. We've worked together in the Children's Hospital over many years. We migrated from the Royal Manchester Children's Hospital in Pendlebury to the Royal Manchester Children's Hospital on Hathersage Road. We call it the New Children's Hospital, but actually next year it'll be 10 years old. Peter is a clinical academic. He deals with some very challenging, rare immune disorders in childhood. He has excellent collaborative links to groups around the world and has been involved in finding the genetic cause of a number of key diseases. And I would also add, in my days when I was doing general pediatrics as well as endocrinology, that Peter is an extremely good clinical opinion, particularly when you've got your back against a wall with a very sick child on the intensive care unit. Peter will often come and sort you out with the right antibiotics, antivirals, whatever. So it's a great pleasure to introduce you, Peter, to come and give your lecture.
Thank you very much, Peter, for that kind introduction. Friends, it's going to be difficult for us all to accept that there are many people in this world who really do not understand, or say they don't understand, what's so exciting about immunology. Let them come to Manchester and the Lydia Becker Institute for Immunology and Inflammation. There are some who say that the essence of immunology is xenophobia and discrimination. Let them come to the Becker Institute and work with Professor Mark Travis and the Immune Tolerance Group. And there are some who say that immunology really does not know any boundaries or barriers. Let them come to the Becker and work with John Granger and the Immune Barrier Group. And there are even a few who say that maybe immunology has something to offer, but it's not really that important in our lives. Let them come to Manchester and hear about life course immunology at the Becker. So I'd like to thank you all for sending in your baby photos, because life course immunology starts at birth and goes through to old age, as you all know. Now, there are a lot of people in this room, and I'm not able to go through the life story of you all. And medicine's becoming more and more personalised, and I want to focus on one particular person, and I'm going to put the photo up here, who actually founded, or is the founder of Life Course Immunology in Manchester. Now, I'm going to ask you to suggest who this might be. Any thoughts? It's not a baby anymore, it's a young girl. Anyone got any thoughts? Okay, so let me give you a few hints. People are not perfect. And children do not always fulfill the dreams of their parents. Indeed, parents do not always live up to the expectations of their children. But about 100 years after Lydia Becker was born, this little girl with the shiny red shoes was born. And her name is Amy Drew. And she died at the age of 6 of a very aggressive cancer. And it was a cancer that was driven by a glandular fever virus. And at the time, her parents and her doctors really felt that there was something going on with her immune system that was driving her disease. But there was not a service in Manchester for children with immune problems 20 years ago. And if reality be known, there was not the technology anywhere in the world that could diagnose this child's disease. So we as academics, if we are going to make an impact in this world, we really need to get out of our ivory towers and away from our walls. And somehow, as someone said before, and I can't remember who, we need to learn to tear down those walls that divide us from the rest of society if we are going to make an impact on real-world problems like those of Amy Drew and her family. And for Life Course Immunology, it was Amy Drew's parents, Suzanne and Ian, who initiated and drove the field. Out of the worst tragedy that can befall any parent, the death of a child, they nurtured a vision that has created an internationally recognised academic, clinical and translational service for patients with immune problems. It was Suzanne and Ian who raised the money and inspired the doctors at the Children's Hospital, the academics at the University of Manchester, and even went up to the chief executive of the hospital trust to drive through the business case that created the fledgling service, which has now expanded into collaborations around the world, from Paris to Freiburg, from New York to Sydney. But what about its impact, initially on knowledge and our understanding? After Amy Drew died, there were a number of other children that we were seeing in our unit who had glandular fever virus, which was leading to lymphoma. And there were some others that had life-threatening chickenpox. So what's so unique about these particular viruses? It is that although the immune system can dampen down the clinical symptoms, the immune system can never get rid of the virus itself. And we did a whole lot of immune tests, and none of them seemed to provide the answer. But what we noticed is although the immune cells were fine initially, with time they seemed to lose steam and conk out. And we had numerous attempts at trying to work out what the cause of this immune disease was. And it was only the advent of new generation sequencing, performed in collaboration with Sylvain Latour at the Necker in Paris, that we were finally able to identify the precise cause of Amy's disease. It was a novel immune disorder, and a defect in a gene called CTPS1. CTPS1 is important in providing particularly T cells with the building blocks that are needed for making DNA. And it was this discovery that contributed to a fundamental understanding of how cells grow, but not only grow, but also survive. Without CTPS1, lymphocytes literally run out of the basic building blocks that are required to make DNA. Thus, although patients' immune systems may be able to cope with pathogens initially, they can't survive the marathon that's required for a normal, healthy life. So that's what the impact is in basic science, but what about the wider field? So one of the things that's being talked about today, particularly in the BBC, is our carbon footprint. We all know about our carbon footprint. Let me introduce another concept in relation to immunology and also CTPS1 deficiency. And that's not our carbon footprint, but it's our genetic footprint. Now, we know that CTPS1 deficiency arose from one individual living somewhere in the northwest of England. But what's happened to all the relatives of this particular individual now? Where are they? So, where are the relatives of this individual? On the back of the discovery of the CTPS1 deficiency, Dr. Tracy Briggs at the Becker, who also works in the genomic medicine, has recently, and the genomic medicine unit of the Becker has now been designated as one of 2 genomic hubs for immunology in the whole of the UK as part of NHS redesignation of genomics. So she studied the CTPS1 footprint using the 100,000 Genome Project and also the UK Biobank. So she studied DNA from about 130 people throughout the country, looking for people that carry the CTPS1 gene. And what she found was that in the northwest, as you expect, there's a high prevalence. And there's also a high prevalence in the neighbouring areas of Yorkshire and also the Midlands. And the further north and the further south you go, the less prevalent this condition is. So we can see how people move around from the northwest to other parts of the country, maybe looking for jobs or employment. So out of a tragedy, we now understand the basic biology that underpins this new immune disease, but also how it moves around our nation. But what about the impact on patients? So what about the impact on other people? This is the brain scan of one of our patients that presented to the intensive care unit of the Children's Hospital in a coma. And what it shows is there are multiple holes in that brain, and that is due to a cancer, and it's lymphoma. And we did a brain biopsy of the cancer, and we found that the cancer was a lymphoma and driven by the glandular fever virus. And we tried standard chemotherapy, and we tried modern biologics, such as rituximab, which is some of the modern monoclonal antibodies, and nothing worked. And this patient was going deeper and deeper into a coma, and the prognosis was extremely poor, and most people had lost hope about this child. So what happened was that Professor Rob Wynne at the Becker, who's also the director of the bone marrow transplantation and gene therapy unit at the hospital, actually saved the day and indeed saved this patient's life. He sourced T cells that had been specifically developed to attack glandular fever-driven lymphoma cells. And what he did is he didn't put them into the brain, but he infused them into a vein. And those cells found their way into this patient's brain, and within a few weeks, the patient was starting to recover and they were waking up. With a bone marrow transplant done in the Children's Hospital, this patient has now recovered. And as you can see by the date of this publication, which was over 15 years ago, Alexandra is now a hairdresser. She's got a boyfriend, and she's living a normal life. So we've got a number of other patients with less dramatic presentations who have also been diagnosed and cured of their life-threatening disease. So in the short 10 minutes I've got, I've only had time to focus on one immune disorder. But there are many others that have been discovered since I started medicine about 40 years ago, which, as you can see, is around 1980. With new generation technology, our understanding and our ability to diagnose and treat these diseases is improving, and it's not to exaggerate it, but at an exponential rate. There have been seminal contributions by many colleagues around the world. And we at the Becker are proud to have contributed to a number of these discoveries and have revelled in the excitement of new friendships and collaborations, not only in Manchester and the UK, but other parts of the world. So let me come to my take-home message. What message can I give you about life course immunology? And I want to take you back 2,000 years to a message which has been going for 2,000 years. So 2,000 years ago, it was Cicero, and he was one of the most influential philosophers and also orators of his time, emphasized that knowledge was power. And what he said was not to understand the triumphs, but not only the triumphs, but also the tragedies of our past, is always to be a child. And as such, the world must always remain in the infancy of knowledge. I put it to you that today we are at the threshold of a new era in our understanding of what makes what we are, what makes us tick, and how our genes and proteins that make up our immune system are critical for our life course. Thank you very much.